More than 30,000 scientific studies could be wrong due to widespread cell contamination dating back 60 years, reports the Mail Online. The news is based on research that suggests incorrect identification of cells grown in the lab could have distorted information in tens of thousands of published research studies. These studies have in turn been mentioned by about another 500,000 research papers, as recently as 2017. The issue of misidentification of cells grown in labs known as cell lines due to contamination has been known to researchers for a long time. The first major report on this problem was published back in 1968. For example, some research papers have reported results for lung cancer cells that turned out to be liver cancer cells. This new research gives an idea of how many scientific articles could be affected. The Mail Online incorrectly implies that some cures or treatments could be ineffective as a consequence. The experiments that would have been affected involved the very early testing of potential drugs in laboratory conditions in vitro research. If these early experiments were successful, research in animals and humans would have followed. Only those drugs that were successful in all of these stages would be allowed to be used in humans. But the findings are still of concern, as they could mean more potential drugs fail when they move from tests in cells to tests in animals. And this could lead to some time-consuming and expensive dead ends for researchers. What are cell lines and how are they used? Researchers often study cells they have collected from normal or diseased human or animal tissue, and then grown in the lab. They do this to understand more about how the cells work when they are in the body. They also use them to start to get an idea of the effects of potential new drugs. For example, will they kill diseased cells but not normal cells? The current research is about cell lines. When cells are grown in the lab, they tend to die naturally after a certain amount of time. However, if they are grown under special conditions, they can keep on growing and dividing to make new cells. At this stage, these cells are called a cell line. The cells can also be frozen and then revived to be grown in the lab once more. This allows the cells to be distributed and shared with other researchers. The most famous cell line is known as the HeLa cell line, named after an African-American woman, Henrietta Lacks, whose cervical cancer cells taken without her consent were used to establish the first ever cell line in 1951. It is important that researchers know exactly what type of cells they are working with, so each cell line is given a unique name and its characteristics recorded by researchers. However, sometimes cell lines are misidentified, possibly because they get contaminated by other cells in the lab. If researchers don't realize, then they could be working with the wrong cells, and sharing their results and potentially the affected cell lines with other researchers. Who has done this research and why? Researchers from the Institute for Science and Society at Radboud University in the Netherlands have looked into the issue of misidentification of cell lines. They recognized that although attempts are being made to tighten laboratory procedures and reduce misidentification of cell lines, little has been done to make sure researchers know which affected cell lines not to use, or to flag research articles that have been affected. They decided to carry out a study that would do three things: establish how many scientific articles have been published based on misidentified cell lines, determine if the literature is getting any better or worse in reporting misidentified cell lines, suggest how to deal with the contaminated literature that is based on studies of these misidentified cell lines. How did they estimate the size of the problem? The researchers searched the scientific databases for reports of misidentified cell lines. In particular, they were interested in cell lines where none of the original correct cell line, the original stock, is known to exist. When this is the case, there is no way to cross-check the identification of a cell line against the original stock. This means that most or all of the cells in the stock may be different to the original stock, or misidentified. Misidentified cell lines are reported to the International Cell Line Authentication Committee's ICLAC database, which lists 451 cell lines with no original stock. The researchers then searched the following databases for articles reporting research studies using these misidentified cell lines: the Cellosource database, the German Collection of Microorganisms and Cell Cultures database DSMZ, the American Type Culture Collection database ATCC, the European Collection of Authenticated Cell Cultures database ECACC, the Web of Science, a scientific literature database. They also identified any secondary published research articles that had mentioned in the references any of the studies using the misidentified cell lines. As well as reporting on the amount of articles they found, the researchers also presented 3 case studies tracking publications about a single misidentified cell line to show how information based on these cell lines can spread. Because this study has relied on researchers identifying and reporting misidentified cell lines, not all cases where the problem has occurred will be captured. What did they find? The researchers identified 32,755 research articles that were contaminated by studying misidentified cell lines. Over half of these papers were published since the year 2000, and 58 articles were published as recently as February 2017. This suggests that the problem is not fading away. Looking at how far the potentially incorrect information from these contaminated articles had spread, the researchers found overall, more than 500,000 research papers were estimated to mention one of the contaminated articles. Almost all, about 92% of the contaminated articles, had been mentioned by at least one other research paper. 46 of the articles had been mentioned in over 1,000 other research papers. 2,600 of the articles had been mentioned in over 100 but under 1,000 other research papers. To give an example of how misidentification can affect subsequent research, there is a cell line called ALVA31. This cell line was established in 1993 from a human prostate cancer, but in 2001 it was identified that the stock in use was identical to a different human prostate cancer cell line called PC3. 56 published articles referring to the ALVA31 cell line were found. Of these, 22 were published after the discovery that the ALVA31 cell line had been misidentified. Of those 22 articles, only 2 mentioned the potential misidentification of ALVA31. Some of these papers were published in 2016 to 15 years after the misidentification was reported. The 56 articles on ALVA31 had been mentioned in 2,615 other research papers. What is the impact of this contamination? The first concerns about contaminated literature were raised over half a century ago. Given some of the contaminated literature found in this study was published this year, clearly this issue remains a pressing one for researchers. Although some articles mentioning the contaminated research may be doing so to point out the misidentification, the sheer mass of research potentially built on false grounds is still alarming. The contaminated literature may have important impacts. The findings of these studies may lead researchers to draw incorrect conclusions and perform additional studies based on these. As a result, these studies could waste both valuable research time and money. On the other hand, the researchers recognized that not all of the papers they identified found serious errors. In some cases, the exact origin or characteristics of a cell line may not actually affect the results of an experiment that much. What steps can be taken to remedy this problem? This is a known problem, and ICLAC has published guidelines aimed at minimizing misidentification issues. Good researchers are likely to already carry out checks to make sure their cell lines are what they think they are. They also take steps to make sure they don't contaminate their cells. This study shows why it is important for researchers to consistently take these steps. The authors of the current research make a number of suggestions for additional improvements to the current situation, including that papers reporting on the discovery of misidentified cell lines need to be clearly labeled so that other researchers can easily find them to make sure they don't spread misleading research in their own publications. Those aiming to clean up the contamination problem should write about the contamination, using social media campaigns and general media coverage to highlight the issue and inspire greater research scrutiny in cases where uses of misidentified cell lines produce a false conclusion. Papers should be officially withdrawn. The findings should not cause unnecessary concern about existing drug treatments. Not all of these contaminated studies would have assessed potential new drugs. If they did, any that showed promise would then have had to undergo rigorous testing in animals, and then humans, before they could be used in routine practice.